ideal gas law, or PVnRT, PV equals nRT. P stands for pressure. If V is your volume, and volume has to be in liters. N is number of moles. R is the gas constant, which we'll see on the next slide. And T is temperature, which needs to be in Kelvin. Your pressure and your R have to match up. The R, which is on the next slide, has the pressure unit of ATM. So any pressure they give you, if you convert it to ATM, you can use the R on the next slide. There is another R that you can use, but make sure that you don't mix them up with the pressure units. So R, which is on the back of your formula chart, is the universal gas constant, 0.08206 liters times atmospheres, moles over Kelvin. So writing it, 0.08206 liters times atmospheres, moles times K. So wherever R is where the 0.08206 liters times atmospheres goes, and moles Kelvin will always go opposite of it. So in this problem, if we were solving for temperature, first we write our equation. Then we're solving for temperature. So our rearranged equation is PV over NR equals T, because we're dividing by NR. So now we're going to plug those in using dimensional analysis. Our pressure is in the right unit. Our liters is in the right unit. So we got 4.47 ATM on top. Then volume goes on top. Temperature is what we're solving for. N is on the bottom. And R is on the bottom. But R has two sets of units, so we need a separate box for it. So again, that's liters times atmospheres goes with R, and mole Kelvin opposite of it. So to cancel my units, my ATM cancel, my liters cancel, my moles cancel, leaving me with Kelvin, which is what I want my answer in. And I need 3 sig figs, so 678 Kelvin. This one is a tough problem. We've got some stoichiometry. First, it says we have methane, and methane is CH4. Methane is reacting with oxygen, so plus oxygen. So this is a combustion problem, and it says we're going to make CO2, and the other product of combustion is H2O. So the first step you've got to do is balance your equation. So pause the video and balance the equation. Restart when you have an answer. So you should have put a 2 in front of oxygen and a 2 in front of water. So in this problem, we know our volume, our temperature, and our pressure for methane. And we know our volume, temperature, and pressure for oxygen. So this is a limiting reactant problem because they gave us 2 reactants and they gave us information about both reactants. So the first thing I have to do is figure out which one is limiting. To do so, I'm going to use PVnRT and solve for moles. Because I have a reaction, the only way to convert from methane to CO2 to calculate my volume, or to convert my oxygen to CO2 is to get it in moles of the substance I'm starting with. So step 1 is convert to moles. So solving for moles, I'm going to divide by RT. So moles is PV over RT. So the first thing I'm going to solve for is methane. So methane's pressure was 1.65 ATM. Then I need its volume, which was 2.80 liters. I need my R, 0.08206 liters times atmospheres, moles times Kelvin. And my temperature, always do your temperature outside the dimensional analysis box. I add 273, giving me 298 Kelvin. And that goes anywhere on the bottom. So multiplying and dividing that, I get 0.189 moles of CH4. Then I'm going to do the same thing with my oxygen. So my oxygen has a pressure of 1.25 atm. My volume was 35 liters. R goes on the bottom. And my temperature plus 273 is 304 Kelvin. Multiplying and dividing, I get 1.75 moles. But I want my answer in CO2. Neither of those are in CO2. So I'm going to do one extra step. 2 moles of O2 for every 1 mole of CO2 gives me 0.877 moles of CO2. And 1 mole of methane for 1 mole of CO2. So looking at this information, I can see that my methane is my limiting reactant. And this is how many moles of CO2 I'm going to produce because oxygen is in excess. So then I can take those moles and convert to whatever I need my answer in. In this case, I need to convert it to volume. I now know moles, I know pressure, and I know temperature. So PV equals nRT. This time I'm solving for volume. So volume is equal to nRT over P. I know my moles. I know my R because it's a constant. And my temperature, I just need to add 273, giving me 398 Kelvin. And then my pressure is already in ATMs. If it wasn't in ATM, I could plug it in and convert it within the dimensional analysis table until my units canceled. So my ATMs cancel. My moles cancel, my Kelvin cancels, leaving me with liters. Multiplying and dividing, I get 2.47, which rounds to 2.5 liters in the correct sig figs. So this one was a long problem because we had to do 3 sets of PVnRT. Sometimes you only have to do PVnRT once or twice or none at all, depending on if you have a balanced equation and what they're given and what you're looking for. Then pause the video and try this one on your own. Restart when you think you have an answer or if you get stuck. So in this problem, we are starting with 2.80 grams of tin reacting with excess HCl, so we know that that one we don't care about. And we're trying to find the liters of hydrogen gas, so the volume of hydrogen. And they gave us the temperature and the pressure of that hydrogen gas. So because we were given grams, we can just do stoic to begin with. So we start with our reactant, in this case, tin. Our whole goal is to get that reactant to moles. Well, it's much easier to get it to moles when you're given grams. From the periodic table, you can get the molar mass of tin. So tin's molar mass is 118.71 grams. And my mole to mole ratio, 1 mole of tin for every 1 mole of hydrogen. So 0.02359 moles of hydrogen. Don't round until the end. Now, we can plug that into our PVnRT equation because we're not at STP and we're trying to find the volume. So divide by P, volume is equal to nRT over P. Well, I know my moles because I just solved for them. My R is a constant. Temperature needs to be in Kelvin. It's not, so 27 plus 273 is 300 Kelvin. And then 710 torr. So my moles cancel. My Kelvin cancels. My ATM does not cancel, so I need one more step in there. And so 760 torr is 1 ATM. Torr cancel, ATM cancel. And you could have done that step on the left or the right, doesn't matter. And then multiplying and dividing. And we need 2 sig figs, so 0.62 liters because we were solving for volume. So the answer was A. But sometimes you need to solve for molar mass. Remember that molar mass, we can plug it in and say that PV is equal to grams over molar mass times RT, because moles is equal to the grams over the molar mass. Or you can just solve for moles and then plug it into your equation. Moles is equal to grams over molar mass and solve for molar mass. Or if it's talking about density, you can use molar mass is equal to dirt over P. So molar mass is equal to dRT over P. D is density, and its units would be grams per liter. Because we're just rearranging that top equation to put G over L. In both of those equations, MM stands for molar mass with units of grams per mole. So in this problem, it says calculate the density So molar mass is equal to dirt over P. And I'm looking for the density. So rearranging that. And I'm just going to say molar mass is M for algebra purposes. So molar mass times P equals dRT divided by RT divided by RT. So density is equal to my molar mass times pressure over RT. But what is my molar mass? They didn't give you your molar mass, but they did give you the substance, sulfur hexafluoride. So sulfur hexafluoride is FX6. So you can find your molar mass and then plug it into our equation. And again, the units were grams per mole. And then our pressure. And then R needs to go on the bottom. And temperature needs to go on bottom. So 28 plus 273 equals 301 K. My Kelvin cancels. And that is all that cancels. So then 1 ATM is equal to 760 torr, which then cancels my torr, it cancels my ATM, my moles cancel, and I'm left with grams per liter, which is your units for density. And so plugging that in, you should get that, which rounds to 528 grams per liter. Go ahead and pause the video and try this one on your own. Restart when you have an answer. So you can do it in a couple of ways. You're given the grams and the volume, so you could calculate the density and then plug that into molar mass equals dirt over P. You can solve for moles and then plug it into your mole equation. Moles is equal to grams over molar mass. Or you can do the equation that was a couple of slides ago, PVnRT or PV equals grams over molar mass times RT. We're going to do the middle example just since we haven't done one like that. So we've got PV equals an RT. Because we're trying to solve for molar mass, and molar mass is related to moles, we're going to solve for moles. So moles is equal to PV over RT. Our pressure is 685 torr. Volume is 0.878 liters. R goes on bottom. And temperature goes on bottom. Make sure that's in Kelvin. Liters cancel. Kelvin cancel. My pressures do not. 1 ATM is 760 torr. And my unit is moles, which is what I wanted my answer in. So plugging that in, I get 0.0313 moles. So now I'm going to use the equation moles is equal to grams over molar mass. Since I'm looking for molar mass, my molar mass should equal grams over moles. Because molar mass is grams per mole. So I know my grams. And I know how many moles I have. So I just need to divide those and put my answer in 3 sig figs. So 79.8 grams per mole. And then I could look at the answer choices and decide what gas that most likely is. Go ahead and pause the video and try this one on your own. Restart when you have an answer. If you said D, then you can fast forward. If you did not, then you should have used PVnRT. And you were solving for volume. So volume was equal to nRT over P. Plugging in those values. The temperature is a -6, which means when you add 273, you should get 267. So be careful of negative temperatures. And then our pressure was 0.985 atm. Everything should have canceled, except your liters, giving you 38.9 liters. Go ahead and pause the video and try this one on your own. Restart when you have an answer. You should have gotten B because that was the closest to the answer. Since they were talking about density, molar mass is equal to dirt over P. And using the same equation that we had earlier, molar mass times pressure over RT equal D. Nitrogen dioxide is NO2, which has a molar mass of 46.01. Your R our pressure is 0.970, and that's atms. R should be on the bottom. And temperature, 35 plus 273 is 308. Make sure all your units cancel. We have grams per liter, which is the units we wanted.